So in today's class, what are we going to discuss is, one sec. Today's topic is little easy topic. Okay. Okay. So today's topic is much lighter topic. Okay, because we are going to solve some of the easiest problem. But anyhow, we are going to solve 3 problems in this one. So it will be straightforward. I will just tell you how to solve. So what are we going to solve is that we have already discussed about 3 equations. One is actually 4 important PDEs we have discussed. One is transport equation. Okay, one is transport equation. Another is heat equation. Another is wave equation. Another is Laplace equation. Okay, so this transport equation mostly covers about the linear PDE in first order. These are all third order PDE. So in third order PDE, there is a classification called hyperbolic, parabolic, and elliptic is there. So these are all going to be covering that topic. So if you study the heat equation, then one type of problem can be studied. Wave equation, another type problem, and Laplace equation, another type problem. So if you study these 3 problems, mostly like the second order PDE, you can cover it almost all the required things. Okay. So in this class, we are going to discuss about heat equation and wave equation. If possible, I will cover the Laplace equation also in this class itself. So let us see that what is the idea. So the heat equation, we know, like we have already discussed. Okay, so the heat equation is something like ut is equal to c square uxx. So this is the heat equation. Okay, so ut is equal to c square uxx. So we are going to see how to obtain the solution for this problem, okay, with some initial conditions and boundary condition. So I'm just going to define this problem for a 1D problem only. Okay, this is going to be assigned for a 1D problem only. I will derive this. How did we arrive this equation? Like the way transport equation, I will tell with some stories also. How did we arrive this equation, which I will tell it later. Probably in the next class or next to next class, I will tell you. So what are we going to do is that we are going to solve the problem. Okay, later part will derive how to obtain solution, how to derive this equation. Later part we'll see. So now let us solve this problem. Okay, on this domain, like x belongs to 0, L, x belongs to 0, L, where L is some finite length. Okay, t is greater than 0. Then I have the condition like u of x, 0, okay, equal to f of x. If x belongs to 0, L. Okay, x belongs to closed interval 0, L, in fact. Okay, and u of 0, t equal to 0, where t is greater than 0. U of L, t equal to 0, if t is greater than or equal to 0. So that means I have a rod. Okay, I have a rod which I'm just going to heat it. Okay, so what I'm going to do is that u of 0, t. So this is 0, this is L, which I'm going to keep it 0. So these 2 positions I'm going to keep it 0 every time. Okay, so that is going to be 0. And u of x, 0. So rest of the places, what I'm going to do is that I'm going to assume that u of x, 0 is equal to some f of x. So initial point, so I'm just taking a rod. Okay, so this position I'm going to keep it as a 0 temperature. This position I'm going to keep it as a 0 temperature. In between, I'm going to vary the temperature. Okay, using some function of x, I'm going to vary. Now this is going to be governed by this heat equation, and then I'm going to obtain what is the answer is going to come. So this is a t equal to 0. Now at t equal to 1, some other answers will come. Okay, so it may be like at this position, when t equal to 1, this is going to be having some different temperature profile is going to come. So that means the heat is going to flow in between. So those part with the physical interpretation, I will tell you later. Now what we are going to do is that we are going to solve this problem. Okay, in general, the heat equation is applied to linear homogeneous PDE. Okay, the whatever I'm just going to apply, this can be applied for general homogeneous PDE also. I can apply. We'll derive this little later. Let us solve this 1D heat equation. Okay, so again, the idea is that we are going to solve this problem. We are going to convert this problem into a ODE problem, and then we are going to solve it. Okay, so what is the general idea? So for this, we need a technique called separation of perimeter or a product solution. Suppose you have a problem. Okay, suppose you have a problem. Some PDE problem is there. Okay, some PDE problem is there, which is going to have something like u of x, y, etc. is going to be there. Okay, suppose I have a problem. In u is a function of x, y, which is going to satisfy some PDE. Okay, some, let's say some d is equal to some d is some operator or some f of u comma du comma d1 u sorry d square u etc is there. Some problem is there. Okay, suppose this u equal to u of x comma y. Okay, u of x comma y can be written as some g of x into h of y. Means suppose I assume that my problem, my solution u of x comma y can be written in this form. Okay, this is an assumption I'm going to make it. Suppose it can be written as a product of two independent functions, g of x and h of y. Okay, this is function of x only, this is function of y only. Okay, it's a product solution. Suppose u can be written in this format, u equal to g of x and h of y. For some functions g and h, it is there. Okay, so more generally, suppose you have a u in n-dimensional problem, u is equal to u of x1 comma x2 comma xn. Okay, and that can be written as some function of that is going to product. This is going to be a product solution of this PDE. Let's say f of u comma du comma d square u comma etc dmu equal to 0. Okay, this is my PDE, and this is going to be the solution of this one. Suppose this can be written as this way. Okay, u of x1 comma x2 comma xn can be written as follows, equal to g1 of x1 into g2 of x2 etc gn of xn, product of n functions. Okay, this can be written as a product of n functions. So u of x1 x2 xn can be written as g1 of x1 g2 of x2 etc gn of xn. So n functions I can write it. Then what I'm going to say, this u, okay, or this u is a product solution of this problem. Okay, product solution of this problem. Same way here, if I have like u f of u comma d square u etc, where u is a function of x comma y, if it can be written as u of x comma y equal to g of x into h of y, then this u is called the product solution of this PD. Okay, product solution of this PD. Now this is the method which I'm going to apply for our heat equation, and then I'm going to. So don't forget about this one. So two concepts. One is that I have ut. Is it visible? Okay. So I have ut is equal to c square uxx is there. Okay, this is the problem, and I have u of x comma 0 equal to f of x. Okay, here x belongs to 0 comma l and t greater than 0, and here x belongs to 0 comma l. Okay, 0 comma l, and u of 0 comma t equal to 0, u of l comma t equal to 0, where t is greater than 0, t is greater than or equal to 0. Okay, this is the heat equation, and I have a product solution. Let us say u of x comma y. Suppose u of x comma y is a product solution of this one. So in this case, I can write as g of x into h of y. Okay, so these two concepts only I'm going to use it for this entire class. Okay, today's class, and then I'm going to solve different problems. Okay, I'll just change small things, and then I will solve them. Let us solve the problem. Let us solve this problem. Okay, so let us solve first one problem, which is very simple problem. Some simple linear PDE in first order. Let us solve. Then we'll go for the heat equation. So what are we going to do? Simple example. Suppose I have u of x. This is my problem. U of x, ux plus uy equal to 0. Okay, so I'm just going to assume that there is a product solution is going to be there. Then what I'm going to see, what is the product solution is going to be there. So u of x comma y can be written as, let us say, x of x into y of y. Okay, therefore what is ux? Okay, it is going to be x dash of x into y of y, because only x is a function of x, y is not a function of x, so therefore it is going to be x dash of x into y of y. Similarly, u of y equal to x of x into y dash of y is going to be there. Okay, so therefore if I substitute over here, this is going to become like x dash of x into y of y, okay, plus x of x into y dash of y equal to 0. Now I am going to define, let us assume that x is not equal to 0 and y is not equal to 0. Okay, x is not equal to 0 and y is not equal to 0. So is it valid? That is a question. Okay, suppose this is x equal to 0 or y equal to 0, what will happen? Suppose y equal to 0. Okay, not both are 0. Suppose y equal to 0, then what will happen? u of x comma y equal to x of x into y of y, this is going to become 0. If it becomes 0, that means I'm just going to get a trivial solution. Okay, but I'm not interested in a trivial solution. Okay, trivial solution is always satisfied. 0 comma, if u is 0, then automatically this is going to be 0. I'm not interested in trivial solution. I'm expecting a non-trivial solution only. So if y equal to 0, automatically you are going to get a trivial solution. If x equal to 0, again you are going to get a trivial solution only. Okay, so if both are 0, I'm going to get a trivial solution only. So I'm going to assume x not equal to 0, y not equal to 0, then only I'll get a non-trivial solution. Therefore, what I'm going to do, I'm just going to divide the entire thing by x into y. Okay, x into y I'm going to divide. So this is going to become like x dash of x into y of y divided by xy. Okay, plus y dash x of x dash of x, sorry, x of x into y dash of y divided by xy equal to 0 is going to come. So this is valid only if x not equal to 0, y not equal to 0. That is valid because I'm looking for a non-trivial solution. So that means what I'm going to have, I'm going to have x dash by x plus y dash by y equal to 0 is going to come. Now, this is going to be, okay, so this I'm just going to write it as x dash of x by, this is going to become like x dash of x equal to minus y dash of y equal to some constant is going to come. Why it is going to be constant? Why it is going to be constant? See here, it's a function of x. Here it is a function of x. Therefore, this division is going to be a function of x. Here it is a function of y. This is function of y. Therefore, this is going to be a function of y only. So that if both are equal, okay, this is function. This left hand side is function of x. Right hand side is function of y, and both are equal. That means when it is going to be equal, because these two are different parameters, these two are equal means it is going to be some constant only. Then only both are going to be valid, because this is another variable, this is second variable. So both variables are, it is saying same. So that means it is going to be constant only. Otherwise, it is not possible. Therefore, you are going to get x dash by x equal to nu and minus y dash by y equal to nu is going to be there. Okay. So now let us consider this part. Let me consider this one and this one. So therefore, this is going to become like x dash by x equal to nu. That means x dash minus nu x equal to 0 is going to come. Similarly, y dash, this one, okay, this part, if I consider, then this is going to become like minus y dash by y equal to nu. That means it is going to become like y dash plus nu y is going to come equal to 0. Now we know the solution for this problem. Okay, x dash minus nu x equal to 0 and y dash plus nu y equal to 0. This is a PDE. So two problems are there. So for this problem, I know the solution for this one. Okay, x dash by x equal to nu means I'm going to have x equal to x of x is going to become like, simply you can write. So this is going to become like log x, etc. is going to come. So I'm just going to put e power nu x is going to come. Okay. Now next one, I'm going to have, okay, y dash, this is going to become like y dash equal y equal to e power minus nu y is going to come. Okay, of course some constant is going to come that we'll deal it later. So in this case, what is going to come? Y of y is this one. Therefore, this is going to become like, what is my solution? So this is the solution I obtained. This solution I have obtained. What is my solution? U of x comma y is nothing but x of x into y of y. Therefore, this is going to become like e power nu x into e power minus nu y. Therefore, this is going to become like e power nu into x minus y. So therefore, e power nu into x minus y is going to be my solution for this problem. This is a product solution. Okay. So nu is a real constant. This nu is a real constant. Therefore, if you take any linear combination, that is also going to be a solution. So therefore, if I put u1 of x comma y equal to c1 into e power nu into x minus y, this is going to be a solution for this problem. If I put c2 into e power nu x minus y, that is going to be a solution of the problem. So like this, I can keep infinite number of solutions. So that is also going to become a solution for this problem. So in fact, I can put some summation. That is also going to become a solution for this problem. Now this problem, second problem, I will leave it to you as an exercise. What you need to do is that using separation of variables, you can just solve this problem. 3u(y)y minus 5u(xxy) plus 7u(xy). So this problem you can solve it, and then you can obtain the solution for this one. So this part I leave it to you as an exercise to explore. Okay. Now let us come to this problem. Okay. Let us come to our heat equation problem. Same thing I'm going to apply. Now what I'm going to do. So this is the underlying idea. So I'm just going to assume here u of x comma y equal to x of x into t of t. I'm going to apply. Okay, so let us solve this problem. Same way. So I'll repeat the same thing for all three problems almost. Okay. So let us do this one. So first I got obtained. So this is going to be u of x comma t. I'll put it. Okay, u of x comma t is equal to t x of x into t of t. Now what is ut? Ut is going to become like x of x into t dash of t. Okay. Now what is ux? Ux is going to become like so here I'll put t dot. Okay, so in order to differentiate, I'll put t dot. Okay, so this is with respect to time. So ux is going to become like x dash of x into t of t. Uxx is going to become like x double dash of x into t of t. Okay, so substitute it over here. Then what you are going to get? You are going to get x of x into t dot of t. Okay, dot means it is with respect to time. Okay, x double dash of x c square into x double dash of x into t of t. Again, I am going to assume this one. Okay, x is not equal to 0 and t is not equal to 0. Okay, if x and t are equal to 0, automatically this is going to be trivial solution. I'm not interested in the trivial solution. So therefore, I'm going to use the same technique what I applied in that equation. So same thing. So if I divide that by x by t, okay, I'm going to divide x by t here. Therefore, this is going to become like t dot divided by t is going to come. I'm going to put the c square also here. Okay, equal to, I'm going to come x double dash divided by x is going to come. Okay, so in this case, again, this side it is a function of t, this side is a function of x. Therefore, both are going to be same, means it is going to become like, it is going to be some constant is going to come. So that constant I'm going to put it as nu. Okay, nu is the constant I'm going to keep. So the logic is that this side is time, this side is space. If both quantities are same, that means it is going to be some constant only it is going to come. Okay, it is not going to be function of t or function of anything. So it is going to be some constant is going to come. So therefore, I'm going to have two equations. One is dt, okay, by dt into c square t will come. So that I'm going to write it as minus mu into c square into t. Okay, so I'm just writing these two equations, this one and this one. Okay, the next this one and this one. So in this case, it is going to become like x d square x by dx square minus nu square x equal to 0. So two equation I have. Sorry, nu x only, not nu square. Nu into x square. Okay. So where nu is any real constant. So can it be complex? Let us see that. Okay. So let us look at the boundary condition now. Okay. So I have this one. U of x comma t is equal to x of x into t of t. Ut is equal to this one is there. Now I have to use the boundary condition. What are all the boundary conditions which I have? I'm just going to try that. So now what I have is that I have a yeah. So now what I have u of 0 comma t equal to 0. Okay, u of 0 comma t equal to 0. What I have here, u of x comma t equal to x of x into t of t. Therefore, if I apply that, this is going to become like x of 0 into t of t equal to 0. Okay, x of x into t of t equal to 0. If t is simultaneously 0, okay, then u of x comma t is going to become 0, because if t is simultaneously 0, this is going to become 0. Therefore, we are going to get that. Therefore, t of t is not equal to 0. Okay, if t of t equal to 0 means it is going to become like 0. So I'm just going to assume t is not simultaneously 0. So in that case, I'm going to get a trivial solution. So therefore, we are not interested in the solution. So I'm going to assume t of t is not simultaneously 0. Okay, so that means what I'm going to have, I'm going to have x of 0 equal to 0. I'm going to have x of 0 equal to 0. Okay. Similarly, u of l comma t equal to 0 implies x of l into t of t equal to 0. Again, same logic. If t of t is not simultaneous 0, then this is going to become 0. U of x comma t is going to become 0. I'm not interested in that solution. So I'm going to assume again t not equal to 0. Okay, so in that case, again, what you are going to get, this is going to imply x of l is equal to 0. Okay. Now that means what I got is that I'm going to consider this problem. Okay. So this problem I'm going to consider d square x by dx square minus mu x equal to 0, x of 0 equal to 0, x of L equal to 0. Okay. This is problem number 1. Okay. So this is the problem number 1 which I'm going to solve. Let us solve this problem and then we'll come to this problem. Okay. Let us come to the time different problem later. Okay. Now let us consider this problem. Now what are the cases we are going to have? I said mu is a number. Okay. It is not going to be a complex number because t of t is a real function and this is the real function. So this ratio is going to be a real function. Okay. This is also a real function. Therefore, you are not going to get a complex values here. Okay. Therefore, you are going to get only real cases only going to come. So there are possible cases. What are all the possible cases? Then if it is a real number, either nu can be greater than 0 or nu equal to 0 or nu less than 0. These are all the possible cases. Now let us consider, okay, case 1. Case 1, let us consider nu equal to 0. Then what will happen? If nu equal to 0, what is the solution for this one? This is going to become like, this problem is going to become like, okay, this problem is going to become like nu equal to 0 means it is going to be simply become like x double dash equal to 0 is going to come. Okay. If x double dash equal to 0, it is going to give x dash equal to a is going to come. If x dash equal to a, I'm going to get x equal to some ax plus b is going to come. Okay. X equal to ax plus b is going to come. Some quantity is going to come. Now it is given that x of 0 equal to 0. Okay. X of 0 equal to 0 means what? B equal to, so this implies a into 0 plus b equal to 0. Therefore, it is going to imply b equal to 0. Now, if x of L equal to 0, this is going to imply AL, already b is 0 due to this condition. So, AL equal to 0. L is a positive number, it's an interval. Therefore, L is not equal to 0, which implies A is equal to 0. Okay. So, that means what I'm going to have, which implies x equal to 0. X is simultaneously 0 because A is also 0, B is also 0. Therefore, you are going to get x equal to 0. If x equal to 0, what you are going to get? Your u is going to become 0. Okay, u is simultaneously 0, which I am not interested. Okay, this is a trivial solution which I am not interested at all. Now let us go to the next one. Next one. Okay, so this is going to be u simultaneously 0, which I am not interested at all. Now case 2. I'm going to take nu greater than 0. Okay, so that means nu is a positive number. Okay, therefore I can write it as some nu is equal to some nu square. I can write it. Mu is equal to some nu square. I can write it. So therefore this is going to become like x double dash minus nu square x equal to 0 is going to come. Now if I solve this one, what is the auxiliary equation for this one? The auxiliary equation is going to become like m square minus nu square equal to 0. Therefore you are going to have two roots are going to come. So m is going to be plus or minus nu is going to come. Plus or minus nu is going to come. Okay. Therefore x of x is going to become like a e power nu x plus b e power minus nu x is going to come. Okay. So therefore what I'm going to have again, if I put x of 0 equal to 0, okay, for this case, case 2, case 1. So this case x of 0 equal to 0. Okay. That is going to imply what I'm going to have, a plus b. Okay, a plus b equal to 0 is going to come. A plus b equal to 0, which implies a equal to minus b. Okay. So now what I have, x of L equal to 0. X of L equal to 0 is going to come. Okay. So in this case, what I'm going to have, this is going to imply a. So a equal to minus b, so I can just put it as a e power minus mu x minus b e power minus mu x is going to come. So this is going to become like a e power minus nu l, okay, and a e power plus nu l, okay, and then b is equal to minus a. Therefore, this is going to become like minus a e power minus nu l is going to be coming there. So a power minus nu l is going to be there. This is also equal to 0. Now you can see that. Okay, so this is going to imply that either e power minus nu l, e power nu l equal to e power minus nu l is going to come, or a equal to 0 is going to come. Okay, so this is going to happen. When this is going to happen, a power nu l equal to e power minus nu L. When this is going to happen? Only if it is L equal to 0, only this is going to happen. Okay. So if this quantity is 0, this product of two numbers, these two numbers are equal means one of the number is going to be 0. So if this is going to happen, then e power nu L equal to minus e power nu L is going to come. So in that case, I can write it as, this can be written as like you can just divide by e power nu L, then you are going to get the number. So only if L equal to 0, you are going to get either L equal to 0 or nu equal to 0 only you are going to get. This is going to be same. Okay, but nu equal to 0 means automatically mu equal to 0. Mu equal to 0 already we dealt with, so that is not interested. Only in this case L equal to 0, L equal to 0 also will become like, the interval is going to become like 0 interval. Okay, nothing is going to be there, so that also I'm not interested. That is also not possible. Okay, so I'm just going to assume L not equal to 0, mu not equal to 0, so which is going to imply A equal to 0. If A equal to 0, then automatically already B equal to minus A, so this is going to become 0. So this is going to imply X is simultaneously 0. If X is simultaneously 0, U is equal to 0. Okay, U is simultaneously 0. Therefore, what I'm interested, I'm not interested in this solution also. Now, last case, case 3, where what I'm going to deal with, I'm going to deal with nu less than 0. Therefore, nu can be written as something minus nu square, I can write it. Okay, mu is equal to minus nu square. Therefore, the problem is going to become like x double dash plus nu square x equal to 0. Therefore, x is going to become like, the auxiliary equation is going to become like m square plus nu square equal to 0, which is going to become like m equal to plus or minus nu I is going to come. Therefore, x can be written as a sin x, a sin nu x plus b sin, b cos nu x. Or a, okay, here I put cos. Okay, so I'll follow the same thing. A cos nu x, b sin nu x. Okay, so therefore, again apply the condition x of 0 equal to 0 implies, this is going to imply a into cos x, so a is going to come plus this is going to become 0, therefore it is going to become like 0, a equal to 0. Now x of L equal to 0 implies, okay, already a is 0, only this part is there, b sin nu L equal to 0 is going to be there. Okay, so now what we have, either when it is going to be possible, either b equal to 0, if b equal to 0, automatically again I'm going to get a trivial solution. Otherwise, what I can have nu L equal to 0, sin nu L equal to 0. But sin nu L can be 0 for many cases. Okay, sin nu L can be 0 for many cases. Whenever nu is equal to n pi by L, okay, LL get cancelled, so you are going to get n pi. Okay, sin x is going to be 0 if x equal to n pi. For all n, you are going to get that. N is belong to Z. So that means what you are going to get, nu equal to n pi by L. In that case, sin x is sin is going to become 0. So therefore, here what you are going to have is that you are going to have many solutions are going to come. Okay, so you are going to get a non-trivial solution here. So what you are going to have, you are going to have xn of x equal to, okay, some bn into sin nu sin n pi by L into x is going to be the solution. Okay, so case 1, I'm not getting anything. Case 2, I'm not getting anything. Only for case 3, I got a solution, non-trivial solution, which is xn of x equal to, so x of x equal to it should come, but this nu is depending on n. Therefore, I'm just changing this one also, xn of x, because this x is depending on two things. One is n, natural number, the integer, and x is also that. So xn is equal to bn sin nu pi by L into x. Okay, here I'm just putting pn because I'm just going to have different constant for different. So this is that solution for, only we solve this problem. Okay, so far we solved only this problem. D square x by dx square are this problem. Okay, only this problem we have solved so far. Okay,
sir. Yeah. Sir, one question.
Yeah, please.
Sir, why we are taking that nu is equal to nu square? I mean, we can say that nu is a positive number and nu is equal to nu also.
You can take it, no problem. I'm just making it convenient so that here once it comes, it will be looking nice. Otherwise, here you will put square root of nu, you will put it. Because here, second order equation, right? So in that case, you will put a plus or minus nu you will be putting. So instead of that, to make it convenient, I'm just putting.
Okay.
Okay. There is nothing
one
yeah.
more question.
Yeah.
In the starting, when you start that u of xy is equal to x of x and y of y.
Yeah.
My question is that why we are taking, how we know that the solution is a function of two that independent functions? Is
That's
it
a
a
good
theorem or
question.
something?
That is good question. Actually, we are assuming this is going to be there in separation of variable. We are going to assume that this is going to be there. That is the assumption I am going to make it. Okay. It is not guaranteed that you are going to get that. For example, this problem u of x plus uy, we have already seen that f of x minus y is also going to be a solution, right? See, you have seen this problem aux plus buy. In this case, you have seen this problem. So this is going to become like ax minus by or bx minus ay is going to be the solution for this one, right? So generally you can take it, right? So that is going to be there. So it is not necessary that it is going to be there. So e power, in this case, I'm just assuming that is going to be product solution. Still, this condition will not be violated, but still I get something like e power nu into x minus y is going to be there, which can be written as e power nu x into e power minus uy. Okay, this is a product solution. So it is not necessary that all your solutions can be covered by this one. If I'm assuming this one, and if I can get some solution, then I'm happy with that. If instead of having no solution, or if I don't have any method to find it, so I'm just going to check it whether this is going to be possible. And it is also not guaranteed that always you get this kind of solution. Okay, if it comes, it comes. If it doesn't, it doesn't. Okay, so you can just use that. So this is just an assumption. Trial and error method. I'm just trying. If there is a product solution, what will be the form of that? That's what I'm trying to find. Okay. So it is not guaranteed so far anything. I cannot guarantee that if we give any equation, any PDE equation, I can use the separation of variable and then find the solution. So for this class of problem, yes, it is there because it is already established one such method, which was Euler's time itself. They have found this one. So that's the one which we are doing. Okay, but it is not guaranteed for all the problems. You can expect that. Any other questions? Okay. Okay, next one, what we are going to do is that, so we are going to take, you can observe that, see xn of x equal to bn into, suppose here n belongs to z I have mentioned, okay. Suppose I put n as a negative number, then what you are going to get is that you are going to get xn of x equal to, okay. So if n is less than 0, you are going to get minus bn into sine n pi by L into x, because minus of sine is going to be sine of minus x is going to be minus nx, so therefore you are going to get. So this one I can make it as some cn, I can write it. Some other constant is going to be cn, I can write it. Therefore, what I'm going to do is that I'm just going to take n is greater than 0. Okay, n is greater than 0 only I'm going to take it. Okay, n is greater than 0 only I'm going to take it. So we are in. So next one. N equal to 0 also I'm not interested, because n equal to 0 means this is going to become like xn of x is going to become 0. That means it is going to become 0. So that also I'm not interested. Therefore, what I'm going to take it is that I'm going to take only this problem. Okay, xn of x equal to bn into sine n pi by L into x, where n belongs to n only. So that means I restricted from n belongs to z to n belongs to n only. Okay, n belongs to z to n belongs to n only I got restricted. Okay, so that part also I got restricted. Now what we are going to do, we are going to solve this problem. We are going to solve this problem. Okay, so let me erase this part. Let me erase this part. So what we are going to do now, for each xn, we are going to have, so our problem is xn of x into t of t. Okay, this is x of x into t of t is there. Since xn is going to be there, so correspondingly I'm going to get tn of t also here. So what I'm going to do is that when nu is equal to minus mu1 square, okay, when nu is equal to minus mu1 square, what I'm going to deal with is that this is nothing but what is nu1? Nu1 is nothing but n pi by L. So it is going to become like minus n pi by L whole square. Okay, this is going to be there. So therefore, this problem is going to become like dt by t minus, so this is n pi by L square, so plus n pi C by L whole square is going to be into T is going to be. Okay. So if I solve this problem, this is a first order ODE problem. So if I solve this problem, this is going to give you, if I solve this problem, this is going to give you Tn is equal to some constant into, okay, Kn into e power. So you can, this is a Tt by T equal to T is going to come. So e power minus this one. So n pi by L into C whole square T is going to come. Okay. Or simply I can put some lambda. Okay. I just kept it as lambda, where lambda is nothing but e power minus lambda n square T, where lambda n is nothing but C n pi by L is going to be there. Therefore, what is your solution is going to come? Your solution is going to become like un of x comma t is equal to xn of x into tn of t is going to be there. Okay, where xn of x is nothing but bn sin n pi x L, bn into sin n pi by L into x, and tn of t is nothing but kn into e power minus lambda n square t, or I'll write it as n pi by n pi c by L whole square t is going to come. Okay, so these are all called eigen functions of the heat equation, corresponding to the eigenvalue lambda n equal to c n pi by L. Okay, so these are all called the eigen functions of the heat equation, corresponding to the eigenvalue c n pi by L. Okay, now it doesn't end here. Okay, so I can just observe this one, kn and bn, this is constant, this is constant. So this together I can write it as cn into, okay, cn into, I can write it cn into sin n pi x into e power minus n pi c square, I can write it. So this is a solution. If you take any linear combination, that is also going to be a solution. So therefore, u of x comma t, I can write it as summation cn into summation some combination, okay, linear combination into, or I can just simply put it as u1 of x comma t, where n equal to 1 to infinity. Okay, so that means I'm going to get summation n equal to 1 to infinity. This one I'm going to write as cn into sin n pi by L into x e power minus n pi by L c whole square t. So this is the one of the important problem in electrical engineering or physics problem. Now we haven't used this condition at all. U of x comma 0 equal to f of x, we haven't used it at all. So now if I put f of x equal to 0, u of x comma 0 equal to f of x, then what it is going to come? So I put x equal to t equal to 0 here. Therefore, this is going to become 1. Therefore, you are going to get, what you are going to get is that you are going to get it something like, okay, I'll erase this one also, about rewrite. So this is going to give you u of x comma 0 equal to 0. What you are going to get is that f of x. So that means what you are going to get, summation n equal to 1 to infinity cn into sin n pi by L x equal to f of x is going to come. So here there are two things I have to mention. Okay, so one thing is that, so this is the basic underlying idea behind the Fourier series, where how the history of Fourier series started from here only. Because here what you have is that you have a series which is going to converge to some f of x. Okay, so now the this is a trigonometric series. Okay, this is a trigonometric series where Fourier developed during the warfare between the Egypt and during the warfare in Egypt. Okay, so at that time it was developed. So here there is a trigonometric series, and I'm just summing it up, and that is going to become like some f of x. Okay, so this is the history of Fourier series which is going to. Now what we are having is that we are having u of x comma t is equal to this one. This is if you can find this cn, okay, if you can calculate what is this cn and then substitute it over here, that is going to be the solution for your heat equation. Okay. Now second point I want to mention is that, see, u of x comma t is equal to summation n equal to 1 to infinity cn into sin n pi x into e power minus n pi c by L square t is going to be there. Now the question is that this is a linear combination is fine, but this is a infinite number of solutions. Okay, means you have a series is going to be there. Now the question of convergence is going to come, because u of x comma t, this is an infinite series. Therefore, you need to understand whether this series is going to convergent or not. Okay, that question number one. Now, even if it is converging, you got to check whether it is a uniform convergence or pointwise convergence also, because it's an infinite series. So in this series, okay, this is a series. So for this series, it's a function of x is going to be there. Okay, function of x and function of t is going to be there. Therefore, you got to check the convergence. Either you got to check pointwise convergence and uniform convergence. Then only you can say that this is going to be there. Also, you got to check whether it is going to be bounded. Okay, even if it is so convergence, you got to check. Then automatically it means you are going to get the boundedness or not. Because if it is diverging, what will happen? If you just put some heat source, okay, here if you are putting some heat source, then it is going to explode like anything. Then you are going to get infinite number of temperature is going to come. So that is the place where you require the analysis knowledge of whether it is going to be convergent or not. Okay, if it is convergent, then only you can say, well, okay, my racket is not going to blast if I'm just giving this much of heat to the racket, or this much of heat which I'm going to give it to that. Okay, so these are all the things which is required for either you do some either you send some satellites to rockets or anything, that is very much required. Okay, so depending on that, it is going to be solved. Okay, so this is one of the important thing. Okay, now how do they solve? So in order to obtain this coefficient Cn, so how do they obtain that one is that they obtain the orthogonality properties of the sin mx. Okay, so sin mx, you know this one, sin nx into sin mx dx equal to 0 if n not equal to m. Okay, this is the orthogonality property of this sin mx. Okay, so using that, you do the integration on both sides, multiply with sin m pi x and etc. Then this is going to become like 0, except when n equal to m, this is not except n equal to m, this is going to become like 0. Rest of the things are going to become 0. Then right hand side you can multiply sin n pi x by l. Then you are going to get that. And simplify this, then you are going to get this. Okay. So the solution for this problem, okay, the Cn, the Fourier series, the solution can be obtained by assuming f of x is piecewise continuous. Okay, if it is piecewise continuous, that means like you have one-sided derivatives, then you can obtain the solution. Okay, so one more important factor we can observe from here is that suppose t tends to infinity. Okay, suppose t tends to infinity, this is going to be negative quantity. Okay, this is going to be negative quantity. That means this is going to very, very small. It is going to be very, very small. That means what it is going to happen, it is going to become like 0 after certain stage. Okay, almost it is going to obtain 0. That means the decay increases with n. Okay, whenever the n is increasing, the decay is also going to increase. That means this heat equation is going to say, suppose I kept some temperatures in this rod, or you take some heat vessels. Okay, you keep it in some stove or something, and then put some temperatures over there. Then what it is going to come after a certain stage, as t tends to infinity, you can see that if you just leave it as it is, after certain temperature, what is going to come? It is going to become like the heat is going to be decreasing after a certain stage, and then it is going to become like 0. Okay, it is going to become 0. That means this will become like cold one. Okay, it is not no longer it is going to be heat. It is going to become like a cold one. Okay, so that is what it is. The physical interpretation is saying. Okay, so this is another exercise where you can solve. So the temperature I have given. Okay, the length I have given 80 centimeter long. That means L is given. Initial temperature is given. The initial temperature is f of x I have given sin pi x by 80 degrees Celsius. Okay, and at both ends here I'm just keeping it different. Both ends are 0 degree only. That means this condition is same. Okay, now the question is that how long will it take for the maximum temperature in the bar to drop to 50 degrees Celsius? That means what you need to find is that when this u of x comma t is going to become 50, that you got to find it. Maximum temperature you got to find. When this u of x comma t is going to become 50, that you got to find. Okay, so you can assume that c square equal to 1.158. Similarly, I have given another problem, temperature, same problem. F of x equal to 1 minus x by pi I have given. So again, you got to use the Fourier transformation, etc. And then you got to find it. Okay, so in another 5 minutes, I will complete the next one. Okay, one more is there with heat generation. So this is another problem where you got to calculate some, instead of CUXX, I have kept some Kach also, some positive number also I have kept. That also you can solve it. Okay, with heat generation. Okay, then the same problem you can put some more condition u of x comma 0 comma t. So instead of u of 0 comma t equal to 0, u of L comma t equal to 0, I am putting ux of 0 comma t and ux of L comma t equal to 0. So instead of this condition, I am putting ux of 0 comma t and ul of 0 comma t. Okay, so same problem here. What I am trying to do is that ux comma I am going to keep. Therefore, what you are going to get, you are not going to get this one. Okay, so you are not going to get this one. Instead, ux is going to be there. That means x dash of 0 into t of t equal to 0. T of t again not equal to 0. Okay, so therefore x dash of 0 equal to 0. Similarly, ux of L comma t is going to be there. So x dash of L is going to come. X dash of L is going to come. Therefore, you got to solve this problem. Instead of solving this problem, you got to use this condition. You got to rederive all these things and then check it whether what is the condition is going to be applied. Okay, you have to do the same thing. Derive the same solution with this condition. You got to do. Okay, this is the another problem. Okay. Okay. So I will just stop it in another 5 minutes. Now what I am going to do is that I am going to do the same thing for the separation of variable for wave equation. Same thing. Now what I am going to do is that I am going to put utt here. Utt is equal to c square ux. Ux of 0 comma equal to f of x. Okay. I have one more condition. Ut of x comma 0 equal to g of x. I am going to put it. Okay. One more condition. Ut of x comma 0 equal to g of x. I am going to put it. Same thing. Remaining things are same. Okay. U of 0 comma t, u of L comma t equal to 0, etc. is there. Remaining things are same. So this is again, this is wave equation. Again, this derivation we will see it later. Again, same kind of things. Okay, whatever I have derived, the same kind of thing is going to come. So in this case, what I'm going to have is that I'm going to have instead of this is t double dash actually, not t dash. Okay, so in this case, what you are going to have is that I will just get this one. I will get I will get two equations. One is nothing but t double dot, okay, divided by t equal to minus plus only, okay, x double dash divided by x equal to some constant is going to come. Let us put mu. Okay, same thing is going to come. So that means again you are going to get two equations. One is nothing but you will get d square t by t square is going to come. Okay, another is going to be same thing, d square x by tx square is going to come. Now let us derive this one for this one also. Okay, so there is one problem. Let us consider this problem. Okay, let us consider this problem. Same kind of logic is going to come. So again, x of 0 equal to t, u of 0 comma t equal to t. So here also same thing, u of x comma t equal to u of x, x of x into t of t. Okay, same problem, same thing. Okay, u of x comma t is equal to, is it visible there? Okay, the top one is not visible. Okay, okay, I'll write it. I'll write it here. Same thing is going to come, so I'll erase this one. Except this one, everything is going to be same. Okay, so what I'm going to have is that I'm going to have u of x comma t equal to x of x into t of t is going to come. Okay, so again do the same thing. So utt is going to become like x of x into t double dash is going to come. T double dot is going to come. Uxx is going to become like x double dash into t is going to come. Okay, so therefore if I substitute this one, this is going to become like t double dot divided by t equal to x double dash divided by x is going to come, which is going to be some constant I'm going to put mu. Okay, so therefore I'm going to have two equations. One is t square t by tt square equal to mu. Okay, and another nu t. Okay, another is d square x by dx square equal to mu x is going to come. So same kind of equation. Okay, again use the same logic. U of 0 comma t equal to 0 means x of 0 equal to x of 0 into t of t. Okay, and ul of t comma t equal to x of l into t of t. Again x of 0 equal to 0, x of l is going to become 0. Same thing. Okay, same thing. Whatever I did, the same thing is going to. Again use the same logic. Nu equal to 0. Okay, nu equal to 0. You are going to get the same logic. Okay, again you are going to get x equal to 0. That means you are not interested at all. Okay, now nu greater than 0. Put nu greater than 0. Then nu equal to mu square. Again use the same logic. Again you are going to get a equal to minus b, and u is going to become like 0. Okay, now you nu less than 0, same thing, obtain that. Then you are going to get x n of x equal to same thing, bn into sine n by x, l by x is going to come, n belongs to z. Apply the same logic. Okay, then what you are going to get at the end, you are going to get xn equal to bn into sine n by x, n belongs to n. Okay, whatever I explained so far, same thing is going to come here. Now the place where it is going to change is this one. Okay, so the place where it is going to change is only this equation, because earlier we had an equation d square. Earlier we had an equation d square. Earlier we got dt by dt we had. Now we are having d square t by dt square minus mu square. Sorry, minus this one, same thing. This one I got to apply, nu is equal to n pi by L I got to apply. So you are going to get it, the equation like plus C n pi by L whole square is going to come. C n pi by L whole square is going to come into T is Tn. So Tn is going to come, okay, because Xn is there, so Tn is going to come. So this is again auxiliary equation. If you find it, then in this case what you are going to get, Tn of T is going to become like An cos, I put it as lambda n T plus Bn sin lambda n T is going to come. Okay, so in this case, then what is going to come? You have un of x comma t, which is the product solution, which is going to become like An cos lambda n T plus Bn sin lambda n T into, I have to apply that Bn into, okay, this is into sin n pi by L into x is going to come. Okay, so that this is, in this case, this is called the eigenfunction corresponding to the eigenvalues lambda n. Okay, lambda n is nothing but Cn pi by L. And that set of all eigenvalues, that is called the spectrum of this problem. Okay, now again same logic. Okay, so if you apply that, then I can apply that summation I can apply here. So this can be written as, okay, this one I can write as this Bn, I can observe it over here. So this is not going to be there. So summation n equal to 1 to infinity. Okay, summation n to n equal to 1 to infinity. An cos lambda n T, Bn sin lambda n T into sin n pi Lx is going to come. Now I got to use this condition. U of x comma 0. This is going to be U of x comma t. So U of x comma 0 is going to be. So I apply this one. So therefore, t equal to 0 means this is going to be 1. This is going to be 0. Okay. Therefore, we are going to get summation n equal to 1 to infinity An into sin n pi by L into x. That is going to become like f of x. Now again use the Fourier series concept and then find this one. Now second one, ut of x comma 0. Okay, ut of x comma 0 means this is going to be minus sin lambda n is going to come. This is going to be cos lambda n is going to come. So this one I can put it some. So in this case, this is going to become 0. Okay, an coefficient is going to become 0. Only Bn is going to be there. Therefore, we are going to get summation n equal to 1 to infinity Bn into sin n pi by L into x is going to come equal to g of x. Again, apply the Fourier series and then find the answer for this one. Okay, so you can calculate An and Bn using the Fourier series concept. Then you can obtain the solution for this one. So An can be obtained in this way. Okay, An can be calculated and Bn can be calculated again using the orthogonality property, etc. Then you will get the final solution. So with this, I will stop. In the next class, I will cover the Laplace equation. If you have any questions, let me know. Any questions? Let me know. This is one of the easiest one. Okay, 3 cases you got to take. Again, this is kind of a ODE problem, PDE problem. We are converting into ODE problem, set of ODE's problem, and then you are solving it and then obtaining the solutions together. If any questions, let me know. Otherwise, I'm done today. Any questions? Are you able to follow what I'm talking? Okay. Okay, if you don't understand anything or any clarification, either you can send an email or WhatsApp me. Thank you.
Sir, thank you, sir.
Yeah, thank you.